Good morning, Rohit. Hey, Sholay. Am I audible? Good morning. Okay, let me share the link. Let me share the link. The link instruction. Okay, so good morning, everyone. Today we will be talking about the pre-stressed concrete. Okay. Um, instead of pre-stressing in high-rise structures. Okay. Before also, I think we have discussed a little bit about this. but okay, let me share my screen. I'll share my screen now. Okay. Microsoft Edge. Okay. So we'll start with the today's topic is Priestess Concrete, and then we'll be after that we'll be looking we'll be going through some of the equipments that are used for the heavy lifting or the light lifting of the uh, construction equipments or materials on the site. Okay, so before that we'll be talking about this concrete, pre-stressed concrete. What is pre-stressed concrete? I think you have an idea about this. What is your pre-stressed concrete? Concrete in which reinforcing steel bars are stretched and anchored to compress it and thus increase its resistance to stress is your pre-stressed concrete. Mhm. I told you before also this thing. I think the pre-stressed concrete. What happens? This is tendons are placed here. This tendons are pulled. These tendons are pulled. These tendons are under tension, and then what happens when you release them? Compressive forces are developed here. When you release these tendons, the compressive stresses are here. So the stresses are developed here. So the stresses will be developed here so that when the external load is applied, it can be equalized with your these stresses. The stresses will those are generated or developed here inside your this suppose this beam. If I'll talk about this beam, then what is happening? The stresses that are developed will resist your this external load. Okay, and will normalize that. So the main difference between reinforced concrete and pre-stressed concrete, what is the main difference between your reinforced RCC and your pre-stressed? Okay, so both utilizes the structural capabilities of steel and concrete. Concrete is very strong in compression but relatively weak in tension. Okay, so RC, reinforced concrete, is your very much strong in compression but little bit weaker as compared to your pre-stressed concrete. Okay, because pre-stressed concretes, they'll have a higher compression strength as well as your higher tensile stress strength also they will have. Okay, because of this huge tendons that are used here in your pre-stressed concrete. Ordinary, now what is your ordinary reinforced concrete? Beam supports a load by developing compressive stresses at the top. But But since the concrete cannot resist the tension at the bottom, it cracks there. This I think I have discussed with you this also, like ordinary RC reinforced concrete. What happens to that? Since your ordinary concrete, reinforced concrete, what happens? It can support loads which are developed here at the okay. What happened? Okay, which are developed at the top. Suppose this is your beam. Developed this year. If you have your the loads are applied or loads are developed, loads are put over here on your beam, what will happen? They will have stresses. The compressive stresses will be developed here at the top, but since the concrete cannot resist the tension at the bottom, because due to this load, what will happen? This is you're going to have this, your beam is going to bend a little like this, but since it is weak in tension, and that is helped by what? That is helped by your steel, the reinforcements. Okay, the reinforcements help you in this tension because these are under, this bottom portion is under tension. This bottom portion in your ordinary reinforced concrete, here at the top you have, here at the top you are having compression. Here at the bottom you are having tension. Okay, due to this bending that will occur here. So what happens when you are using your ordinary reinforced concrete? Here at the top it has compressive stresses at the top, it can help, but at the bottom, since it cannot resist the tension at the bottom, so you will see that cracks are developed here. Okay, you will see cracks developing. Okay, so another one is what? Another thing is reinforced steel bars are placed within this tension zone to resist the tension and control the cracking. Okay, so in the ordinary reinforced concrete, since this should have been, your bottom portion should have should be able to resist the tension, so we use what? Reinforcements are given here at the bottom. You will see the reinforcements are given to resist the tension. Okay, so we have pre-stress concrete. Now, what is your pre-stress concrete? Your pre-stress concrete, it involves the application of forces tending to bend and compress a concrete element in order to counteract bending which results from loading. The force applied is the tensioning or stretching of the steel component, which usually in the form of high tensile strands, wires, or bars. Likewise, we told the here in pre-stress concrete, what is happening? The forces here it will the suppose this is your pre-stress concrete. Already the since it is pre-stress, so the stresses will be developed before any external load is applied here. Okay, before any external load is applied, and then in order to counteract the bending here, because since you will have your tendon, so it will be pulled and then it will be under tension, then again when you leave it, it will be under compression, and then these forces will be developed, compressive forces will be here, so that will resist or help the concrete in counterbalancing the bending, okay, which results from this loading, right? So the force applied in the tensioning or stretching of the steel component, which usually in the form of high steel strands, wires, or bars. So high tensile stresses, or how to develop the tension so that you can give back that compressive stresses here, develop these compressive stresses. You have to use in precious concrete the high tensile strands, these high tensile strands or wires or bars. Okay. So now what is, when you know your pre-stress concrete, what is your pre-tensioning and post-tensioning? There are two methods of your developing your pre-stress concrete. How you can develop or how you can make your pre-stress concrete, it can be method, two different methods are there, which is one is pre-tension, the other is your post-tension. Okay, so what is your pre-tension pre-stress concrete? The beams or elements are constructed on a stressing bed, and stranded cable is placed between two buttresses anchored to a stressed bed which holds the force after stretching. Okay, these are things we I just tell you, when you have this concrete in pre-tensioning, what happens? In pre-tensioning, what you will do before any, your concrete is placed, before any concrete is placed here in this form of beam, you are placing your tendons, you are pulling, giving a pull to the tendons with the help of your hydraulic jacks. Stretching is done of your this tendon with the help of hydraulic jacks here. So you will pull out these tendons. Okay, after pulling out, what you'll do, this is done pre-tension, right? Pre-tension means what? Before you are applying this concrete, before you are applying concrete here, you are pulling this tension and then you are anchoring this tendons, and after you are pouring the concrete, you have given your concrete here. Okay, when the after that, what happens? You will leave the concrete to reach its sufficient strength so that it attains its uh, required strength. Then what will happen? The pre-stress force is transferred. Now these your pre-stressed force from the tendon, when you have already pulled, these are under tension, these tendon is under tension. So what will happen when you, now when your concrete, now when your this concrete has already set and has attained its desired compressive strength, okay, then what happens, you are going to release this, you are going to release these tendons which are anchored after pulling, these are anchored here at both the ends. So now what you're going to do, after it has attained this desired strength, the concrete, oh, okay, so what will happen, we will release the tendons. Okay, we are going to release the tendon. Okay, so what will happen, this pulling was done from both the sides. Now once your concrete is attained, it has attained its desired strength, what happens, we will leave or release this tendons, we'll cut it here, and then this is going to come back, this is going to come back and give the compressive stresses, it is going to develop the compressive stresses. Okay, right, so this is your pretensioning. Pretensioning, the mean is what, that before any concrete is applied, your tendons, these tendons are under tension, these tendons are pulled under and kept under tension. Okay, now what is your post tensioning? Post, or as the name suggests, obviously you know that your post tension is what, when you have your beam, you have your tendons. Post means what, this was when you have given the concrete, it has it has it has attained its desired strength, then what happens, we released. Okay, so before the concrete was poured, the tension was given to the tendons, but here in post tensioning, after you have given your concrete and then it has it has attained its desired strength, then we release this tendons, but the tension is done after you have poured the concrete. So what will happen, okay, steel cables inside the plastic ducts, here your, before any tendon is placed, your duct will be formed here. You have poured the concrete, before that you have your one duct also present here. Duct means a narrow, a space, empty space, so that you can enter some pipes or some, that those kind of materials, the narrow, thin kind of materials or any kind of materials. Duct means a space, narrow long space, pipe like. Okay, okay, so what will happen, these duct, okay, I'm sorry. Okay, so now this duct, before, here your plastic ducts are here, one duct is supposed placed here before any concrete is applied, and here steel cable is also put inside. Okay, so these, okay, so uh, okay, so we have here, we have given the duct here, then what we are doing, we are placing the steel tendon here, right, but we have not, remember, we have not given the tension, that means we have not pulled the, this tendons, this blue color tendon, we have not pulled it. Afterwards what happened, once the concrete has gained, now you see, we have this was your duct, the red one, this box kind, this narrow one. So this was a duct. You have placed the tendon inside the duct, and then what you have done, you have poured the concrete. Okay, now, but you have not pulled the tension, pull the tendons for tension, for developing tensions. Likewise, like in here, you have before the concrete was poured, you had already given tension to the tendons, but here you have not given the tension to the tendons. Okay, So only the duct you have placed the tendon. After that, you have poured the concrete. Now, when the concrete will set, your concrete is going to set, and then it is when the desired strength is gained, then what we do? Then we pull this blue color tendons. Then we will pull this blue color tendons. Okay, this will be under tension. Okay, after that, what we are going to do, we are going to release this, and then again in the same way, like the pre-stressing develops, stress will be developed here, compressive stresses will be developed here. Okay, so the main difference between your post and pre-tension and the post tension is what? That here, before any concrete is applied, your pre-tensioning is done, and here tensioning is done after your concrete is applied. Okay, now, process of the post tensioning. How you do the post tensioning? Rules of post tensioning cables are used. Pulling anchors for post tensioning cables. Position post tensioning cables. Okay. Post tensioning cables ends extending from freshly poured concrete. Hydraulic jacks are used to pull the cables. Pre-tension pre-stress concrete is usually fabricated away from the job site in a pre-stressing plant. Okay, this is important. This one, you know, this one is important here. What happens? Your pre-tension pre-stress concrete is usually fabricated for both the from the job site in a pre-stressing plant. Okay, in a pre-stressing plant. So that means when you are developing the pre-stress concrete by the method of pre-stressing, here pre-tensioning and post-tensioning, right? So when you are developing your pre-stress concrete by your this pre-tensioning, what happens? You are fabricating that pre-tensioning you are doing, that means the precast pre-stress concrete which you are developing, you have to develop that away from the site in a pre-stressing plant. But in post-tensioning, what happens? In post-tensioning, your pre-stress concrete, the application of pre-stressing forces to the structure is done. The application of stressing forces to the structure is done at the job site. Okay, right? So that means what? You're pre-tensioning away from the job site. You will make that you'll give the tension, you will pull the tendons, you'll give tension, then again you develop cut the tendons, and then you will release the tendons, and then you will develop the stresses. But in the post tensioning, what is happening? In the post tensioning, on the site itself you have to develop the stresses. That means on the site you can release the tendons. Tension may be done before also, but on the side you are going to release the tendon so that the stresses are developed on the side. Okay, now what are the tensioning devices that we use? So the tensioning devices are your mechanical device. The mechanical devices generally used include weights with or without lever transmission, geared transmission in conjunction with pulley blocks, screw jacks with or without gear devices, and wire winding machines. These devices are employed mainly for pre-stressing structural concrete components produced on a mass scale in factory. Okay, so mechanical devices will be used, your hydraulic devices will be used for large pre-stressing force extensively used as tensioning device. Hydraulic devices will be used to pull the tendons, right? Then electrical devices will be used. Why? Because you will need obviously the wires are electrically heated and anchored before placing concrete in molds, right? This method is often referred to as thermo pre-stressing and used for tensioning of steel wires and deformed bars. Okay, for pulling the tendons, you will need your hydraulic device, but for anchoring them, you will need your electrical devices. Then chemical devices, expanding cements are used, and the degree of expansion is controlled by varying and curing conditions. Since the expansive action of cement Okay, this is incomplete. Okay, so leave this point. So advantages of, now we'll be talking about the advantages of your pre-stress concrete. So what are the advantages of your pre-stress concrete? Advantages is its lower construction cost, thinner slab, which are especially important in high-rise buildings where floor thickness saving can translate into additional floor for the same or lower cost. Okay. Fewer joints since the distance that can be spanned by post-tension slabs. So when we use a pre-stressed concrete, we can decrease the thickness of our slab. Okay, because it is giving that much strength, right? Um, if you have two concrete slabs of the same thickness, but this is precast, this is normal RCC, then what will happen? Same thickness it has, but this is going to give you more strength as compared to your this thickness. So if we can get the same strength, or more strength as compared to our normal RCC, more strength as compared to our normal RCC, then we can obviously decrease our, if we do not require that much, we can decrease our thickness of the slab. Okay, so obviously when you decrease the thickness of your slab, what will happen? You can include another story in your building. Okay, otherwise in the normal RCC, what will happen? If the slab thicknesses are more, you will, as compared to this 1 2 3 4 G plus 4, so in the pre-stress you can add this extra floor, but because you can, since you're decreasing the slab thickness, right? So but in the case of RCC, this one may not be included. So disadvantages in high-rise buildings using your pre-stressed concrete: longer span length increase the usable unencumbered floor space in buildings and parking structures. Okay, fewer joints lead to lower maintenance cost over the design life of the structure, since the joints are major locus of weakness in concrete buildings. So when you're using pre-stressed concrete, you have fewer joints, not like unlike the RCC ones, because you have many joints in the RCCs. You will join column to beam, beam to column, and many other joints are there. So, and the joint is only the main location of your weakness of the concrete. So if we can use fewer joints, okay, so why not? So that is why pre-stressed concrete is important. Then a disadvantages, some of the disadvantages are also there for your pre-stressed concrete. Like the major problem with pre-stressed concrete is that it needs specialized construction machineries like jack and bridge, because when you're using your pre-stressed concrete, you will have to have huge large machines like jacks, big anchorage systems. But obviously when you are constructing a very high rise building, when you are constructing this high rise building using your expenditure is your expenditure is very much high. That means you have your amount which you want to invest is okay. You have that much of money, you are given that much of money, but the quality is more important to you. And the quality, and also the taller building if you want, then extra you want in lesser material, then you can use this. Obviously we'll use the priestess concrete, whether it requires jack anchorage, huge machines or not, because in bridges also, huge bridges, because we are concerned with the strength and the durability of that bridge. So and we need the construction also to be fast. We cannot give more workers for your construction, maybe due to some circumstances or something like that. So what will happen? So manpower you don't require more there, so you can make the precious concrete, bring on the side, and then you can join, or you can on the side itself you can do the post tensioning. Okay, advanced, one of the, again, another disadvantages is advanced technical knowledge and strict supervision is very important, because this is tricky. Your precious concrete is not easy enough to do by any layman or any. You have to need some special supervisions. Under special supervisions, your pre-stress concrete is to be developed. For concrete pre-stressing, high tensile reinforcement bars are needed, which cost greater than generally used mild steel reinforcement bars. So in RCC, we use normal reinforcements, mild bars or HYSD, so that is lesser in cost as compared to your high tensile, the this high tensile wires, you can see, or high tensile strength tendons. But the initial cost may be more, like the when you're selecting or buying this tendons. Okay, purchasing these tendons, you will have the initial cost may be more, but you're also getting advantages, right? Because you have the greater tensile strength, you will have greater number of floors, you will have weight will be lesser as compared to the RCC ones. Okay, so initial cost will be obviously more as because of these tendons also, and the heavy machines which are used. But later, but on the long run, you have a more greater strength with your pre-stress concrete. Okay, highly skilled labor is needed for pre-stress concrete construction. Now, mm, let me do another one. This was your pre-stress concrete. Another one I have, yeah, notes. Erecting. Okay. Cell structure we have done. Erecting. Okay. So now when we have done with our pre-stressing. So I'm sharing my screen again. Microsoft Explorer. Okay. So okay. So now, when we know about the pre-stress concrete, we know, but now we'll talk about some, yeah, how we can erect the lightweight components on tall structures. So when you're constructing tall structures, how you can, uh, we'll just have a discussion on it. Besides high-rise buildings, the uses of steel element is also popular with construction work. Okay? Instead of concrete beams and columns, more than 6,100 tons of steel have been used to build the main frames. Lightweight blocks are used for patricians to reduce the dead load building. Okay, lightweight blocks are also used. The uses of permanent concrete from works and structural steel elements will be the main constituent for erecting. Okay, the uses of, you see here, the uses of permanent concrete formworks and structural steel elements will be main constituent for erecting lightweight components on tall structures, which will result in the rapid speed of construction. So when we have, why we need to erect lightweight components on tall structures, because the we will need, when you have tall structures, you will have to, it's difficult to take your materials from the bottom, from the ground to your fifth floor, 58th floor or 38th floor if it is too high. Okay, so hence the erection of steel beams and columns as well as the installation of concrete formwork consumes only less time. Self-drilling tapping screws are most prevalent. Self-drilling tapping screws are most prevalent fasteners. Steel to steel connections can be carried out to connect, okay, struts or joists and track together. Entire can be erected manually without the use of heavy equipment. All these structures require few battery powered screw guns and some ropes and pulleys. No scaffolding is required for assembly and disassembly of the structure, because the structure itself provides the scaffolding as it goes up or comes down. Okay, so when you have, I think you have seen that, when you have a tall structure, you will have suppose two steel pipes are fixed here, and then you have here some trolley kind of thing, so that This is moving from here to here. This one will be lifting your materials, whether it be light or high. It is going to move from here to here, whether it be any floors. Okay, so suppose this is one floor, this is one, this is one, this is one. So many are there. Okay, so many floors are there. So what you're going to do, you're going to fix this steel pipes or elements. Okay, for erecting our lightweight components, we will use then this trolley kind of thing, which is going to move here on these pipes, which is a structure itself. It can also be used sometimes as a column when these two, this, this one and this one can be used sometimes for the your structure members steel column also. And then on that only we can use this trolley, and then uh, help in moving the materials from one floor to the other. Okay, no scaffolding is required for that. Otherwise, what we do in the normal RCC, we develop the scaffoldings. We develop scaffoldings, we form the formworks, okay, and then we do the works, But in this, what happens? It is automatically moving. You will need here only machines. Almost any number of column sections can be added to make it any height we desire. Okay, so those steel equipments or the steel columns can be used for any height fixing when you fix with the help of screws. Okay, drilling taping screws you use, and then join those steel columns, and then that columns can be used for your transferring of the materials. Okay, now the support structure for use with heavy equipments. Support structure, what are the support structure that are used for use with heavy equipments? A support structure is adapted to support vehicle mounted equipment, okay, in an elevated stored state above ground, and further adapted to mount onto a bed of a vehicle to assist in loading and offloading of equipments. Okay, so there can be, okay, there can be sometimes you may, in some of the constructions, you may need what, you may need heavy equipments which are vehicle mounted. That means some kind of vehicles, small vehicles, or heavy instruments are to be transferred to your top floors. So there can be some equipments, there will be some equipments which are vehicle mounted, which support this vehicle mounted, and they will transfer the vehicle to that desired floor length. Okay, to help the loading and unloading of the equipment. The vehicle comprises a support frame. Now, what does this vehicle, which is mounted on the equipment, will help in loading and unloading? So, this vehicle comprises of what? A support frame, first and second rigid leg structure. Okay, so support frame, first and second rigid leg structure mounted to the support frame, and a pair of stop elements. The first rigid leg structure include a first pair of legs, each pivotally mounted to the support frame on a respective pivot axis, so that each leg includes a ground engaging portion located on one side of the axis and a second portion located on other side of the axis. Each of the leg is pivotable between a support position wherein the first portion engages the ground and stout position wherein the leg is oriented proximate to the support frame, with the second portion extending into a region between the support frame and a respective pivot axis. Each of the stop elements is selectively movable into the region to define a stop position wherein the stop element obstructs the region to prevent pivoting of the respective leg into the stalled position. The stop element is further movable, okay, out of the reason to permit pivoting of the respective leg into the stalled position. Okay, so to use to the support structure, this equipments are there. Those kind of equipments where they have these, the first and the second rigid leg. This is the first and the second rigid legs are mounted. Okay, to the support frame. Suppose your frame. This is the frame. This will be these two legs of the your equipment will be mounted. Array. Okay, so the first rigid leg includes your first pair of legs. Each will be mounted here to the support frame on a respective axis. Okay, now that each leg includes the ground engaging portion. Here another. Okay, this was the frame of your support frame here. Okay, let me share. Okay, let me share your link first of all. Where is okay? What happened? Okay, building construction. Hmm. Okay, I'm sharing the link. Whoa. Give you attendance there. What is that? 432. Okay. We can give you, I have shared the link with you for your attendance in the chat box. You can just check the link and give your attendance. Am I audible? Ivan CVS. Can you share the today note in group? Yeah, I'll share till now whatever I had discussed. I'll share those notes in your WhatsApp group, and also I think I have shared the previous ones. So after that, whatever is left out, those notes I'm going to share with you all. Okay, together I'll share all the notes. I'm thinking whenever I get time, I'll compile and give it to you, because otherwise I may leave out some of the some of the notes. So I'm giving it one by one, because the previous earlier to this class, I think I have not shared those notes. So together I'll send. Okay. Okay. Okay, then let us leave for today. You can go for your next class. Thank you.